All right, I'm going to go ahead and get started. We still have people rolling in, but I want to get you guys in and out of here in a reasonable amount of time. My name is Ryan Stankovitz of MidNite Solar, and I believe Rachel's in here as well from MidNite Solar. And today we wanted to do the webinar on installation examples using our rapid shutdown equipment, predominantly in a battery-based environment. Last week we did the grid tie environment, and now we want to talk about the battery-based environment. At the end, we'll talk about some of the new stuff coming up, how some of our new product will actually play with rapid shutdown, and how much easier it may get, and how much harder it may get, depending on what you're trying to accomplish. Again, like I mentioned earlier, anybody that does have any questions, please just show them in the question pane on your right-hand side of your screen. I'll get to them as we go. I encourage you to ask them as we go, not hold them until the end. I am going to leave everybody muted just because of the size of the group. It would be probably quite impossible to unmute everybody. So no further ado, we're going to jump right in here and we're going to talk about rapid shutdown in a battery-based environment. And if everybody should see my slide change here. There we go. If my slide didn't change and show a firefighter, please somebody holler. But what is rapid shutdown? Before we go too far into how we do it, let's talk about what it is. And in 2014 NEC, National Electrical Code, 690.12 called out rapid shutdown. And basically in a nutshell, it told us that we were going to have to shut down the PV array within 10 feet of the array. Anything outside that 10-foot boundary would be what we call controlled. Anything inside that boundary is uncontrolled and can be whatever voltage it was before the fact. Anything outside that boundary must drop to 30 volts or less. 2014 code was written, said that must happen within 10 seconds. There has been an amendment to the 2014 code that is now 30 seconds. That gives the capacitors a little bit longer time to bleed down. It's a little bit more realistic. And that's pretty much it in a nutshell. It was very vague in 2014. It basically said that it had dropped below 30 volts, and below 8 amps. And it did have this one clause that said, anything 5 feet or longer inside a building. And that's been used to maybe misinterpret or interpret this however you will. The powers that be that wrote a lot of this never really intended for rapid shutdown to apply to the actual batteries. So if you have a 48 volt battery, they never really meant for the 30 volt limit to apply to that 48 volt battery. The 5 foot inside a building was really more for, say, a ground mount array that might come into a building, run through a shop and over to an inverter. That's what they were really targeting, was the PV, conductors, if you will, the wires between the PV array and the device, regulating that PV array. That being said, a lot of inspectors interpret this to mean that it needs to take care of the batteries as well. A lot of fire officials are asking that we shut off battery-based inverters because, let's face it, for those of you in here that are firefighters or know somebody that is, the biggest concern the firefighter has is the 120/240 volts AC in the building. It is not necessarily the PV so much. A lot of them might not even know what that is. But the first thing a firefighter will always do on a scene is to try to get the electricity shut off to the house. So it seems kind of boggling to me that we would institute rapid shutdown but allow us to leave the 120/240 of a battery-based inverter turned on. So a lot of people are doing this basically because they feel it's important to do that for the firefighter. Some are doing it because the inspectors are requiring it. Whatever that case may be, that's what we're going to talk about today. And at the end, we're going to go ahead and go into a little bit of detail on 2017 as well. I'll give you a little heads up for those of you that are not familiar what's coming. So with rapid shutdown, you're going to have what we call the initiator and what we call the initiated device. We'll speak to them as that, the initiator and the initiated device. In our case, the initiator is what we call the birdhouse. It's available in red or gray. You can have up to 4 birdhouses on a single system. Basically, this system combines together with 600 volt 8 conductor cable, and it's a string, if you will. Everything goes in one long series string. So you can have 4 birdhouses. They just need to be ganged together in that string. So if you were going to do 4, all 4 could be in the beginning, all 4 could be at the end, however you may want that, but you couldn't put one at each end. And that's got to do with the feedback and the keep alive signal. If you was to put one at each end and the cable got damaged, the two would still see part of the system, and the systems would act as two separate systems at that point. So that's an important thing to note. All birdhouses must be grouped together. Another thing that I would like to talk about a little bit is the 600 volt cable. We call it Cat5 cable. It actually uses the 8-pin RJ45, I believe it is, Cat5 connector. But you have to be really careful calling it Cat5 because Cat5 is a digital format, not an analog voltage signal. And we actually use all analog voltages, low current, low voltage. So that cable can be put in the same pipe as your PV wiring, for instance. If you say Cat5, and you guys can't see my air quotes here, but I'm, Cat5 in quotes, your inspector is going to think digital, and he's going to think noise, and he's going to say, I want that in a separate pipe. So just be careful about calling it Cat5, even though it follows the Cat5 pinout. The biggest reason we decided to follow the Cat5 pinout was simplicity. It's something that a lot of people already know how to do. The other thing is that you can walk into any Home Depot or Walmart and pick up a 100-foot long pre-made cord that you could throw in your toolbox. When you're having a problem and the tech support guy says, well, we think you got a bad cable, you've already plugged that cable in, and you can tell them, no, you don't know what you're talking about. We've already verified that. Help me out here. The other thing we do is inside the birdhouse, we give you a cable tester. So if this is new to you, making Ethernet cables, we give you a cable tester to allow you to test that cable after you make it. So we try to make it as painless as possible, but it is still making Cat5 cables. Again, like I said, available in red or gray. The biggest reason for that, originally it was in red, and I got a call one day from a frantic person in Somersville, Massachusetts, who will remain nameless, but he had just been shot down on a job from the fire marshal because it was red. Massachusetts, a lot of the New England states still use the actual fire boxes that look quite like this. So that's something to be aware of. If you're in the New England states, you probably want to order the gray one. If you really have your heart set on red, you might want to check with your inspector or fire marshal first. I wouldn't say it's an actual code requirement, but I will tell you that in Somersville and Boston area, the fire marshal will not allow a red birdhouse, period, end of story. So there is a red and a gray model. You get to pick which one you want. One of the interesting things about our birdhouse is that we give you positive feedback. In the early days, UL said they were going to require feedback because this is, after all, about firefighter safety, and we want to know that the firefighter is safe. We want him to have a warm, fuzzy feeling. Firefighters are it's drilled into a firefighter that no power line is safe to touch ever. It's always dangerous. Always consider it live. And now we're telling the firefighter, go ahead and push this button and trust us that 600 volts or 1,000 volts or whatever that PV voltage may be is disabled. So we went ahead and we put the positive feedback in there, which actually verifies the switches are open and everything. UL does not require that, so that is pretty unique to us. Most manufacturers do not include that because it does add a significant cost. Moving on, dry contacts. So the birdhouse actually has a dry contact in it that can trigger a fire alarm, or in this case, it's very handy for shutting down a battery-based inverter. So for those of you that are familiar with the Outback inverter line, you'll know that they got that little jumper you can remove and the inverter shuts down. You can actually wire that jumper to the birdhouse, and when the birdhouse is initiated, it will actually shut the inverter down, and that saves you a lot of time and aggravation, as you'll see later on battery-based breakers and all that. But that can also be used to trigger a fire alarm if you're in a commercial application, etc. The other thing we have in the birdhouse that's not mentioned here is we have an input, so the birdhouse can actually be triggered by something else. So let's say we're in that same commercial application, we can actually interface the birdhouse with the fire alarm system. So if somebody pulls the fire alarm in the Home Depot building, it's going to shut off the PV array automatically, no intervention needed. One thing that is different about our birdhouse system than a lot of rapid shutdown systems, our birdhouse system will actually shunt trip the combiner box on the roof. It actually opens the breaker. It's actually a switch, not a breaker. It actually trips that into the open position. So you do have to physically go reset it just like you would any other circuit breaker. A lot of products use contactors and will turn back on when you apply the power back to them. But when you start mixing components into the battery-based world, it's really hard to do that. You really need a system that shunt trips everything and leaves it in a safe state. The birdhouse does require a 120 volt dedicated circuit run to it. It does have rechargeable batteries inside it that keep everything alive, and it will operate on its own 2 feet. If there is a power outage, the system doesn't shut down. It will go several days before those batteries go low. And then the last thing it does is it shuts the system down to protect you if the batteries do go dead. I do have a comment here that the Schneider Electric also has emergency power off contacts in each inverter, and that's going to become quite a bit more common as we move forward. Products are going to be developed with rapid shutdown in mind across the board. We're all working towards that. SunSpec is actually working on some standards to help with that. So, we are thinking about the guys out in the field trying to install this stuff, and we're hopefully going to try to make it as painless as possible, although 2017 does add some of that burn back in. So, initiated devices, as we talked about before. NEC says these must be within 10 feet of the array. They do not specify in what direction. So as you've all probably seen, the grid tie inverter 12 feet off the ground screwed to the side of the house underneath the array does meet the intent of rapid shutdown, although it doesn't meet the intent of serviceable equipment, I suppose. But mount these within 10 feet of the array. They are available. All of our products are available in either 3R or 4X. They are all powder coated aluminum. We have combiners that do up to 16 strings. We have pass-through boxes for dual channel MPPT. We have shut-off boxes for single high current devices. We have models for grounded and ungrounded arrays, as well as convertible models. So if you decide you're going to do a Schneider 600 volt MPPT, we have versions of this box that will handle that. If you're going to do 4 classic 150s, we have versions that will handle that, as you'll see coming up. Again, as it says, a full range of models for virtually any installation from grid tie to off-grid. One of the unique things about our product line with these combiners is that we include everything that's needed, the strain reliefs, the hole plugs, lightning arresters if applicable, etc. So when you open the box, you're actually going to lug parts home. You're not going to be looking for anything. You're going to have your strain release for your 1000 volt PV wire and everything else. I did say 1000 volt there, so I do want to point out that our product is only rated for 600 volts. We are working towards 1000 volts, but nothing on the docket at the time. And got a question of what is the minimum string units we have? 1, 2, 3. So the minimum string combiner we have is a 4-string combiner, but we do also have pass-through boxes that do just a single in, single out, or 2 channels MPPT in and 2 channels MPPT out. This box in the picture is actually 4 strings in to 2 separate strings out. So you see on the left-hand side here we have 2 negatives, 2 positives. They would go to one set of bus bars. The other one would go to the other set of the bus bars through 2 completely separate, isolated electrical switches. So this would actually be for maybe like a 10 kilowatt PV array into a 10 kilowatt ungrounded inverter where you have 4 strings, but you have dual MPPT. And then remote trip breakers, which is really the heart of this discussion today. The combiner box stuff is all pretty straightforward, but the remote trip breakers is where it gets a little interesting because there's more than one way to skin the cat, if you will. Just know that we do have a variety of remote trip breakers available in AC or DC and different current levels. We have 250 amps, we have the small, amperage breakers, we have 600 volt breakers. So we can be pretty accommodating when we need to do something with that. Another note that I want to throw out there, especially to this group today, is that if you're not using what we call the dash PSB or the power supply board, in other words, if you do not have a combiner in the job and you still want to use the birdhouse to trip one of these breakers, you must use this MNFX cable. And basically what this does, in a nutshell, the birdhouse sends a charge signal up to the power supply board in the combiner to charge a big cap up there. And it watches that cap to make sure that it's healthy and ready to go to work if needed. So if that cap is not there, the birdhouse sees that and assumes that the combiner box is bad, and it's going to shut the system down and holler at you that you have some bad stuff going on. So this just basically tricks the birdhouse into believing that the combiner box is still there and happy. We never really dreamt that anybody would use this system without a PV array, And since we designed it, it's amazing to me the uses people find for this. One of the ones I think of is a battery room. The battery room had a single point of entrance, and the inverters and everything were on the other side of a wall in a separate room, and the inspector wanted uh, an external disconnect for that battery bank. And the customer that called me was looking for a NEMA 4X 250 amp rated battery disconnect. And it's like, boy, we don't have one. If we did, it would be stupidly expensive. And just think about all of the 4-aught cable that you're going to need to run. Actually, probably much larger than 4-aught if you're running it that far. You know, if you go from the battery bank out through the exterior wall of this box and then back through to the inverters, you could be talking 30 or 40 feet of cable, and that's going to get really crazy. So we put together a system where we used a birdhouse and this 250 amp breaker over here and this FX cable. And the birdhouse is on the outside. It gave them the disconnect they needed to pacify the inspector, and they were able to run the low voltage cable in and save a ton of money on that. I do have a question about the MNFX. Is it needed if there is a BDM in the system? And yes, it is, because basically the PSB gives live feedback on the status of the actual switch through a limit switch in the combiner. The BDM, which stands for Battery Disconnect Module, is what controls all these remote trip breakers. And the way it gets its feedback is it watches the switched side of the breaker. And when it sees the voltage drop, it knows the switch actually opened, and then it sends a signal back to the birdhouse that, hey, everything's good, the voltage is safe, we accomplished what we tried to do. So the FX cable is definitely needed because it replaces that big cap that's in the PSB that the birdhouse is expecting to see, if you will. So that should take us through our boring rundown of what all the product is. Hope you're not all asleep on me here, and we'll go into some examples. So probably undoubtedly one of the most common systems that you may install, single inverter, 4,000 watts, 5,000 watts, single charge controller. In this case I show a classic, but it could be any charge controller, 600 volts or less. I'm going to show you two examples of doing this. One would be meeting the bare minimum of NEC, which is just disconnecting the PV. The other one will be showing you how to disconnect the PV and the AC to the building. In this case, this is a 120-240 inverter, happens to be the Magnum PAE. So example one, and I do want to mention quickly that this is available as a PDF later, anybody that wants it, because these slides do have some small bill of materials on them. But example one is basically showing you that you could have a PV4 HV, a PV6 HV, or a PV8 HV, depending on how many strings of PV you have. You know, you may have 4 strings going into a classic 150, or maybe, you know, 4 strings going into a classic 250. But in any event, you know, you would size this combiner based on the number of strings, just like you typically would for any other system. Just pick whether you want a 3R or 4X chassis. And also note that anytime you're ordering this product, always order it with the dash PSB. And then what happens is you get the factory installed power supply board, and you don't have to install it out in the field. We don't charge you anything to install that. It's just the cost of the board. It's easy for us to install it during assembly, and we do a function test on it. And that's well worth it. It's kind of a tight little spot to get into, and you will, especially this time of season, you'll be swearing at me out there in the field trying to put the little screws into that and wire it up. So as I said, mount this within 10 feet of the array, pick the right box based on the number of strings you have to disconnect to the charge controller. The black wire here is your PV wire coming over. The blue wire is your control wire. And now most inspectors are probably going to make you use something like this because most charge controllers out there, or I probably say all charge controllers, anyone I've ever tested, will not bleed down within the 30-second requirement. The PV capacitors hold a charge for a pretty extended period of time. So you're probably going to be forced to do something like this SOB 3R 2-pole. This is also available in a 4R if wanted, 4X if wanted. But this would go as close as possible to the controller, and this would be your disconnect coming in, and this would also interface with the birdhouse. So essentially at this point what's happening is when you shut the birdhouse off, you're actually disconnecting the wire here and disconnecting the wire over here, so the PV wiring is completely disconnected, dead, 0 volts. So that would be just doing the PV array. And if, oh, sorry about that, I can't scroll down. If you look down at the bottom, you'll see the bill of materials, the one birdhouse red or gray, the proper combiner, the SOB if needed, the Cat 5 cable, etc. So this is the wiring diagram. Assuming that you're all familiar with a combiner box, I'm not going to bother to draw that, but this shutoff box that we had in the earlier picture over here, this one right here, this is what it looks like internally. It's basically two 300 volt poles. So when we use those for a ungrounded inverter, for instance, we run negative and positive through them. With switching both sides, we can switch up to 600 volts. We use them for charge controllers. In the case of a classic, we can do two different charge controllers at 300 volts each. Or if we needed to do a Morningstar 600 volt or a Snyder 600 volt, we could actually put a jumper in here, which will be shown later in the slideshow. So this allows for up to two charge controllers. The previous example obviously only showed one, but if we did have two controllers, this would be the same box you'd need. And you have a max of 75 amps per circuit here in this device, which is pretty much going to cover you for any of the controllers out there right now. The Classic will do 96 amps on a 12 volt battery. The Magnum PT100 will do 100 amps. So you're pretty much not going to be pushing much more than 60, 70 amps on the input side if you're getting that much on the output side. So this is a pretty universal box for that. It is load break rated, meaning you can open it under load. And again, as I said, it can be used for a single 600 volt controller, and we'll talk about that a little later. So now we're going to go ahead and shut off the battery-based inverter as well. This is where it gets a little bit more interesting, but it's really pretty simple when you see it. I do apologize for the pictures on this. I have not had a chance. Originally, this BDM came in a 24 or a 48 volt flavor, but we have now made it universal for jumper on the board, and you get to select the voltage that you need for that. So disregard the dash 24 and the dash 48. You would be just ordering MN BDM, and that's it. Another note I want to throw out there is there are a couple ways to handle this. Typically in a battery-based inverter system, you would have your charge controllers connected to the battery side of this breaker through their own positive breaker, and that way they're isolated from each other. You can, if you move the charge controllers to the switch side, you can do away with this box. And when you shut this breaker off, what happens is the charge controller and the inverter are now still tied together on the DC bus, and they drain each other's caps almost instantly. So there's a couple ways to skin that cat. This is the most safe way, but it's, I shouldn't say safe, it's the most foolproof way without getting in any mischief on an existing system, but it does add a little cost to the system. Again, same thing down here, you've got your bill of materials. One thing that's not drawn in this picture is the control circuitry, and I think we come up to that in a minute, but there would be a wire going from the switch side over to the feed for this board to power it, and in that we would want to put a breaker just to protect that. There is fusing on this board, but really to be safe we do want to put a breaker on that feed. And here's what that would look like from an electrical standpoint. This battery disconnect module, or BDM, gets a positive and negative feed. The negative would just go to your negative bus bar in your inverter system, your breaker box, either your E-panel or your Snyder PDP or your Radian GSLC, whatever it may be. You'd have a negative bus bar on your shunt somewhere, and this would go to that. The positive wire goes to the switched side of the breaker. If you put it on the hot side of the breaker, what's going to happen is you're going to hit the birdhouse. It's going to tell you the system was not shut down, and this is going to just sit there and keep clunking the breaker, just clunk, 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 just trying to shunt trip it. Even though it's already tripped it, it doesn't have that feedback through that, the lack of voltage to know that it's actually tripped it. And here's that breaker I talked about earlier, drawn in just to protect that circuit board, because remember, we're talking 250 amps here, and you may be using, 18 or 24 gauge wire here, whatever you need to use. You do want some protection on that just to be safe. And then there's the two wires that go to the shunt trip breaker. These are not polarity sensitive. They're drawn here as purple and yellow. It's going to depend on the breaker you get, what color they are. Some of the breakers actually have studs that you would crimp on the wire on end on your own wire, put under the stud. Some have spade terminals where you do like a 1/4 inch quick connect, plug, crimp on, and then some have actual wires hanging out of them. So that interface is going to be up to you in the field, but it is not polarity sensitive. So moving on to a probably just about as common system, we have, this could be off-grid, this could be battery-based grid tie, this could be self-consumption, but we're going to go ahead and really beef this up. This is, we'll call it a couple XW pluses, the 6848s. So we're looking at around a 14 kilowatt inverter system, and we're going to go ahead and put 4 classic 150s on here just to really beef this up and show a full-blown system. Same thing as before. Example 2A is going to show just the PV. Example 2B is going to show disabling everything. And as I talked about earlier with the 2-wire, that you can open on these inverters and shut them off, I'm not actually drawing that in. That's something that we could draw at a later date. If that's something that you want to do and you need some assistance with that, reach out to us and we will, we'll draw that up for you and show you how to do that. Pretty similar to the last single inverter system. What we're seeing here is, you would have your combiner boxes. This could be a PV8 or a PV16, and the reason I say that, this is showing using a single box for 2 separate PV arrays. Remember, the 8 and the 16 are what we call convertible, and they can do 2 outputs. So you could run 4 strings into one side of this, 4 strings into the other, and then output 2 separate output circuits for 2 separate charge controllers. Or you could do 2 PV4s or 2 PV6s or even 2 PV8s, depending on how many strings you need. So you just have to look at the PV array configuration and determine what's going to be the most cost effective, how many boxes do you want. Sometimes this isn't always as feasible as 2 separate boxes because sometimes the array is a little spread out, and running all your wires back to a single disconnect versus putting 2 that are a little bit more separated and close to each string or each set of strings makes more sense. For instance, if you're doing a ground mount and each ground mount fed a single charge controller, you wouldn't want to run off one ground mount and go over to the other one to get to this box. You'd want to put one box on each ground mount just for simplicity for your sake. So I don't go into a lot of detail on this because this is basic sizing of a combiner box. And if there is any questions on that later, feel free to reach out to me. I can definitely help on sizing combiner boxes. Again, shown here, you got your blue wire that goes box to box, and then over to the birdhouse, and it leaves here and goes to another box. That birdhouse could be virtually anywhere. Like I say, it could be over here on the end of this system electrically. It could be over here. That's just showing, pretty basic wiring. One thing I am showing here is using the SOB 4X 4-pole -PSB to disconnect all 4 charge controllers in a single box. That is completely possible. Just keep in mind that you are talking about, you have 8 number 6 wires here possibly, maybe even larger coming in here. So that can get a little busy. That's just, that may determine what you do. You may decide to do 2 of these boxes instead of a single one just for that single purpose. Again, a little bit of a bill of materials down here. Shows the terminal block in here that you would need to do this because remember, these are all grounded, so we're going to use a separate negative terminal block in here just to combine all the negatives and run them back out to the common charge controllers. Now do keep in mind that the Classic has common negatives, and what I mean by that is all 4 PV array negatives can be bundled together at one point or multiple points if needed, and it's not going to affect anything electrically. You do need to consider current flow with all of that, but just remember that you can commonize those negatives. If you had a Snyder, for instance, the XW MPPT 60, the 150 volt controller, you cannot do that. The PV negatives have to stay isolated all the way to the charge controller so they can do current sense. I'm going to move on to some questions real quick. Do the MidNite shunt trip breakers fit in other manufacturers' power panels, specifically the 175 and 250 amp? And generally speaking, that's a big yes, because they're the exact same breaker we all use. Everybody in this industry uses the same breaker. And the way that shunt trip breaker is set up, there's a box on the back of it, and if you take the Phillips screw out of that box and take it off, there's two single wires. So if the mount was on the back, like in a PDP, for instance, on the Snyder, you may have to drill a hole in the mount to get those two wires out through, but that's the only thing that you would ever run into. If it's a front mount panel, like the FlexWare, for instance, wide open, easy to go, any of our E-panels easy to go, that would be the worst thing you'd run into, is just getting those two wires through the bracket if the breaker sets on the bracket instead of being mounted from the screws on the front. And how many devices to one birdhouse? So the official statement is 12 combiners and unlimited BDMs. Because remember, the BDMs are self-powered, so there's really no limit to that. The combiners are charged from this guy. So there's a certain amount that you can put in series before the voltage drop gets enough that it wouldn't trip anymore. We have tested up to 16 with no problems, and if you get into a scenario where you need more than 12, I'm happy to, set that up and test it and get an engineering statement on that. The other one that I normally get asked, I haven't seen come up for a question yet, was how far away can things be? And we have tested up to 1,600 feet between two devices with no problem at all. So again, same statement. If you find yourself needing to go 4,000 or 5,000 feet, give us a call. We'll mock it up and see what happens. And then, would you recommend putting the SOB before or after the charge controller input breakers? That's really, it's really up to you as the electrician on site. Electrically speaking, I don't see why it would make any difference. Conveniently speaking, it could be more beneficial to put them after the breaker, because you would then have smaller wire. A lot of times this wire going between the combiner box and the charge controller out in the field can be quite large because of voltage drop. You may only have 60 amps on it, but you may have to go to a number 2 because of voltage drop. So that would make it a little bit more problematic coming into here, whereas that number 2 would land on your breaker no problem, and then you could go with your number 6 into here, and have it a lot easier, 2 wires. So it would really a lot depend up to what you feel comfortable with and what lends itself to the system as best as could be. If these are ground mount arrays, of course, this all doesn't matter over here if these are ground mount arrays, or let's say the wiring's coming in from the outside for some reason, from a second building. You've got panels on a shop, and then they run over through conduit, and then they're going into the house. Now you have to have rapid shutdown on the shop because the panels are over there, but you also need an external disconnect where they go into the building at the house. So this could be considered your external disconnect. So that would really vary on case-by-case basis. Could I speak on nuisance trips, what would cause them and how to prevent them, and what happens if the Cat5 signal cable is damaged? Good questions. So first I'll start with the Cat5 cable. If the cable is damaged, rodent damage, fire, whatever the case may be, the birdhouse is going to detect that, and it's going to shut the system down, and it's going to very annoyingly tell you the cable is damaged and please call your installer. So it is fail-safe. Any damage to the cable, being it shorted or open, it's going to see that, and it's going to shut the system down. Nuisance trips, what could cause them and how to prevent them? I think I've had some really fun ones in my career here. Probably the most entertaining one I've had was a customer who swore that my birdhouse was shutting the system off every night, and we sent them a new birdhouse, did the same thing, and they finally set up a game camera and found out that one of the neighbor's kids was coming over and pushing the button every night. So they ended up super gluing the doors shut and figured that the firefighter would be able to pop the door off, with no effort at all, but it seemed to keep the neighbor kid out of it. So one of the more common causes can be somebody actually pushing the button. After that, the next thing I see a lot is water damage, moisture damage. Remember, these are basically using a Cat5 cable, and they plug in to the boards with regular Ethernet jacks. So a little bit of moisture in there can cause some interesting issues. We do ship everything with silicone grease, but as some of you know, not everybody uses the parts that are shipped, and not everybody reads the manual enough to know what that was even for. The cable plugged in, it worked, they left, a little moisture builds up, and you get a little corrosion on those pins, and now it trips. So I would say those are the two common ones. The third common problem I've seen is there's a jumper inside the birdhouse, I believe it's JP4, that enables the batteries in the birdhouse. If you do not install that jumper, and you apply 120 volts to this, the birdhouse is going to work just fine. As soon as 120 volts goes away from a power failure, the birdhouse is going to shut everything down because it sees the dead batteries. So that's another common one I see. The other thing I've seen is that the installer will install that JP4, run it through a cycle test, and then, 2 or 3, 4 weeks later, when utility gets there and activates the system and the 120 volts comes out to here, the batteries are dead, and then they've got to charge, and that's a slow process. So there's a couple little quirks there. Definitely reach out to us if you have any other questions on that. So just quickly, this is a schematic for that shutoff box doing all 4 charge controllers. Like the last one, this one is just double the fun. It's 4 breaker poles, each pole being good for 300 volts, and actually the poles are good for 100 amps. The limitation is the terminal blocking the wire. That's rated for 75. So you've got 4 inputs and 4 electrically isolated outputs. Each one of these is good for 300 volts max, and like I say, you can do up to 3 classic 250s with that, or 2 600 volt charge controllers, as we'll show later. Bear with me for a minute, I'm just cleaning up some questions. So here is the same system, but now we're disabling the battery-based inverters as well. One of the common questions I get in the system is, can I use a single battery disconnect module for 2 of these breakers? And technically the answer is yes and no. One board will physically trip 2 of these breakers. The problem is you can only get your feedback from 1 breaker. So if you was to get feedback from this breaker and trip both, and for some reason this one didn't trip, for whatever reason may be, the coil's burnt up in it or whatever the case may be, this birdhouse system is no longer going to know that this inverter is still on and making power. So for that reason alone, we say no, 1 MN BDM per breaker, and that's just how it is, and that makes it for a safer system and guarantees you your feedback. Again, please note the -24 and -48, that is no longer a thing. It is just the MN BDM now, and that will be user selectable for 24 or 48. We do not have a solution for 12 volt, but we find that most 12 volt systems are not going to apply by any of this anyways. 12 volt has become fairly uncommon, I think, in the large scale stuff, especially the inspected stuff, I think may be a fair statement. Same thing down here for your bill of materials, and same thing up here, just showing now you could come out of this box, the blue wire, and go down to the 2 BDMs, or you could come out of here and go to the BDMs and then back to that box. The flow really doesn't matter as long as you go in a long string. The polarity of these jacks does not matter. There is no in and out on these. On the jacks inside here, there is definitely an in and an out, and they are very clearly labeled upstream and downstream, in birdhouse. So that's pretty explanatory. It is in the manual as well, but do pay attention to polarity on that. That is another common tech support call that we do take on the disconnecting combiners. And here is the electrical schematic for those 2 BDMs. As you can see, nothing special, exactly the same as the last one, just double 2 of them. Same little breaker there. And this breaker can actually be used as an override. That's another thing to think about. When you put that birdhouse system in, and let's say the mouse does chew through that cable up on the roof, and the birdhouse shuts the whole system down because it detects a bad cable. Now your customer doesn't have a battery-based inverter either because that's shut down. If you turn this breaker off, you can actually turn this one back on and run the inverter, and this will not have any power to trip this, and the system will stay in a what we call limp mode until you get there to fix the cable. So this can be considered an override too for the battery-based breaker, so you can turn that back on. That's important to note when you get that call at midnight and the customer wants their power on, and you can walk them through that without driving out to the site. So the last example here that I want to go through is basically an AC coupled system. You've gone in, customer's got a Sunny Boy TL, and they now have buyer's remorse and want some backup power. They've called you in to add this, and well, unfortunately now you're opening a can of worms and you have to make the system comply with rapid shutdown, whatever the case may be. we're going to show you how to disable the PV and how to disable the complete system, just like we did in the other ones. So as you'll notice on the first slide, I showed a Sunny Island. On this slide, I'm showing a Magnum. Trying not to show any favoritism. Pretty much works for any battery-based inverter all the same. You're just turning off the breakers. I would note that I don't show a Radian in here, but if you are doing a Radian, the Radian actually has 2 breakers. So each GSLC is going to need 2 of the remote trip breakers and 2 of the battery disconnect modules. Just something to note. Same thing as before. Mount the combiner or the disconnect box within 10 feet of the arrays. In this case, it's a 5 kilowatt TL inverter. So we're doing 1 string into one channel, 1 string into another channel. There's no combining at all in the system. So this box is basically just breaking both strings, outputting both strings. This box may or may not be needed based on the PV cap charge. We really haven't talked about that in a grid tie world, but just like in the charge controller, your grid tie inverters will hold a charge on the input cap for a period of time. So what I would recommend is you either ask the inverter manufacturer, are they rapid shutdown compliant? Do they meet the 30 seconds? Worst case, you might have to do your own witness test and see if they bleed down in 30 seconds. I wouldn't necessarily suggest just throwing this box in no matter what. I would verify the inverter first and then do the box. That being said, if the inverter bleeds down in 40 seconds, I would probably call the inspector before I left the box out because it's going to be a lot harder to put it in after the fact. Same thing over here, the 3R or the 4X, 4-pole with PSB, depending on which version of the box you want. The 3R box can lay down from vertical being 90 degrees, it can lay down almost all the way to horizontal to 13 degrees, which is about a 312 roof pitch if I remember correctly. The 4X can go in any orientation. And then in an AC coupled system, the grid tie inverter ties to the AC out of the battery-based inverter, and the utility grid feeds into that. And this tricks the grid tie inverter into staying online. So then we get a simple little bill of materials down here. Again, this one may be optional depending on your inverter, and X many feet of the Cat5 cable. This is showing how to wire that same SOB, but now we're wiring it for 2 strings of 600 volt PV instead of charge controllers. So we would do the PV negative and the PV positive from string 1. It would go through that switch and out to the input channels of the inverter, and the same for string 2. So pretty straightforward stuff. And now we're going to add the remote trip breaker, just like we did before in the off-grid system. We're going to use a regular MNBDM and an RT 175 or 250 amp breaker, depending on which inverter you're using. And we're going to trip that with the birdhouse, just like we did before. Pretty straightforward stuff there. Here's your little bill of materials down here. So that's the end of our examples. We're going to go into some, we'll call it options, if you will. Some things that we can do differently than we talked about before. We talked about using the SOB to shut off the charge controller inputs. Let's say you're doing a couple classic 150s and you've got one of our E-panels. Maybe you're doing a Snyder XW and you got an E-panel. You can actually throw this 100 amp 2-pole RT breaker in there. Even though it's sold as a ground fault device, it has 1 pole that's remote trip. It has 2 poles that are 100 amps. And you could use this for 2 classics with the BDM inside the E-panel. And that probably is going to be cheaper than buying the SOB with the PSB. So it's something to look at for those of you that are comfortable with that and don't mind the extra wiring, or just want this to be your PV disconnect at the same time. Now this one breaker covers both. Unfortunately, it is a 100 amp breaker, so if the wire is smaller than number 4, you're going to get into mischief with that. You would still need a breaker to protect the wire, I think. Consult your local electrician for that one. But just know that that is an option. If you're doing a couple charge controllers, you can use this. You could. The other thing you could do to this too is you could put it on the battery side of the Classic. If you had a Classic 150, you could use a 100 amp breaker on the battery side, and then when you shut off the battery side of the Classic and the PV array out in the field, the whole Classic is going to bleed down instantly as well, and that solves the problem. But because it's 150 volts, it's it's 150 volts, 100 amps. So you could technically use it on all 3 of our Classics on the battery side of the Classic. and this is just showing the wiring schematic for this. You would get this schematic with this breaker, so you wouldn't necessarily need to watch this, but there's a lot going on here. This is your shunt trip pole. This is one of your high current poles. This is the low current pole that we're actually using to protect the wire and feed the device at the same time. That way it gets its feedback when that switch opens, and it protects it because it's 1 amp. And you've got your other high current pole. And we talked about using the SOB 2-pole for a 600 volt grounded charge controller. So let's say you're going to use the Morningstar 600 volt controller and it's a grounded controller. You can't run 600 volts through just one of these switches because it will burn it up when you open it. So this field installed jumper makes it a series circuit and puts these 2 poles in series like we do in the factory, and now it's good for 600 volts. And as you can see here, you'd bring your 600 volt up to 75 amp in, and it would come back out here and go to your charge controller. So that pretty much brings me to the end. I will hit a little bit on 2017 as you guys hopefully give me all sorts of questions. Those of you that are not familiar with 2017, there was 2 active work groups working on the new 690.12. One was sponsored and run by the Firefighters Association of America or something to that effect, basically run and handled by the firefighters. The other one was done by Solar ABCs and a bunch of us manufacturers that got together. Unfortunately, the firefighter version won out, and well, fortunately or unfortunately, depending how you look at it, and now we basically have, in 2017, everything is controlled. So if you've got a PV array on your roof and you're running the wires down to your inverter, 2017 says that anything 1 foot or more outside of that array is one controlled zone. Anything inside that 1 foot boundary, in other words, if you draw a line 1 foot around the solar modules and 1 foot below and 1 foot above, that is one controlled section. That controlled section inside the array has to be down to 80 volts or less within 30 seconds. 80 volts was picked because that is considered the max voltage out of a 72 cell module in the coldest climate you can find. The intent of that was that you would basically disconnect every module from each other. They stopped short of calling it module level shutdown, and I try not to call it that because there are some exceptions where you might not actually be doing that. Let's say you're using the Dow peel and stick module that's coming out and there's no grounded components. There is an exception to that rule that the array with no grounded components doesn't have to apply to that 80 volt limit. But for the most of us, that 80 volt limit is going to be a issue that we're going to deal with. We're going to be 80 volts inside the PV array, and we're going to be 30 volts outside the PV array. All has to happen within 30 seconds. We went from about 4 or 5 sentences in 2014 to a whole bunch of paragraphs in 2017. So it's much more defined. It makes it more clear in 2017 that this is not intended to affect the batteries. Of course, batteries, or energy storage if you will, have been moved out of 690 and given their whole chapter in NEC, and I do suspect that you're going to start seeing some requirements on that side, for firefighter safety as well. But for the most part, for 2017, we're going to be dealing with what we probably will end up calling module level shutdown, meaning every single solar module is going to need some kind of electronic gadget on it to disconnect it from the one beside it, because the way it is written, it does say that you cannot measure more than 80 volts between any 2 conductors or any 1 conductor and ground on the PV array, meaning that you wouldn't really technically even be able to bring, 2 modules together and then bring them to a single shut-off device. The one shining light in that, if you will, is that they are giving us until January 1st of 2019 to comply to that. So if you're in a jurisdiction like Massachusetts that adopts 2017 code on January 1st of 2017, you have 2 years before that clause inside the array boundary takes effect, and you have to abide by that. But that is going to be interesting. We are working on some stuff, as well as a lot of other manufacturers, that will be low cost, be PLC driven. So you'll have a little transmitter either built right into the device on the ground, or that just snaps on over the lines. and sends a signal up through the PV lines, and then you'll have receivers on the PV modules that will listen for that signal, and we'll try to keep the cost as low as humanly possible on that stuff. The one good thing about that is that Brian from Fronius, Brian Leidick, got a hold of me a long time ago and said, if we're going to be pushed into PLC communications, we really should have a standard for the industry. So we get together with SunSpec and we have developed an industry standard that allows an SMA inverter to control a MidNite receiver, if you will, or a MidNite transmitter to control a Solar World receiver. So that's going to be a little bit better for you guys out in the field, but still it's going to be a change. I do have a question. Do these module level shutdown apply to the ground mount arrays too, or just roof mounts? So still in 2017, this is only applicable to structure mounted PV. This is not applicable to ground mounts. I don't know if that will change, sort of like everything else has, but in 2017, it's still only on structure mounted PV. And structure, that's a loose term. I've seen inspectors say that's a pole barn that the farmer stores his tractor implements in. I'm not going to make him do rapid shutdown. Typically what I see it come down to is if it's a building that you would put fire insurance on and expect a paycheck out of it if it burnt, and expect the fire department to fight if it burnt, then you're probably going to be required to put rapid shutdown on it. Fun example is I've got a distributor up in Canada who does a lot of off-grid systems literally out in the middle of nowhere. One comes to mind where the nearest fire department is 7 or 8 hours away. There literally is no fire department. There is no fire insurance. It is, buyer beware. It's, use at your own risk. The inspector was making them do rapid shutdown for the firefighters. Well, there are no firefighters. So that was an interesting one. But that does, each scenario can be slightly different. And that's where you need to get up with your electrical inspector or your fire marshal and figure out what's going on. I think we've answered most of the questions. Kept you guys darn near an hour, so I don't want to keep you too much longer. We will be probably doing, I'm not sure where we're going next with webinars. That's going to be a Rachel call. She gets to pick what we do. So if you've got any interests or any thoughts, by all means, reach out to Rachel and tell her what you'd like to see us talk about. If you'd like to see us get down in the weeds more on something, or if you'd like to see us be more general and cover more product, we would love to see that feedback. And we really want to throw out a great big thank you for all of you taking an hour out of your day here to listen to me ramble about rapid shutdown. And anybody that does want a copy of this webinar, just send us an email, webinars, plural, @midnitesolar.com, or shoot me an email over here at ryan@midnitesolar.com. This is being recorded. I will get it up on YouTube here probably in the next couple days, and I can send you a link to that, or a PDF copy, or whatever you like. Rachel, you got anything to add?
Not at this point, just thank you everybody for joining us.
All right, well, as Rachel said, we do want to throw a big thank you to you taking time out of your day and listening to us. We're going to wrap this up and look forward to seeing you all in another webinar in the future. Thank you for coming.